Hello students, good morning. So today our topic of discussion is parallel AC circuits. How we can solve the parallel AC circuits. Here this is simple diagram of parallel AC circuit. In this circuit, R1 and L is a combination of series RL circuit and R and C is the combination of series RC circuit, and these two branches are connected in parallel with the AC source. So how we can solve this type of circuits? So here first method, here we have three methods to solve parallel AC circuits. Let me explain one by one method. First method is by phasor diagram. By phasor diagram, let's see what we will do in this question. First of all, let me take a question. Suppose here we are having value of R is 50 ohm R1 and value of R2 is 75 ohm and value of L is 0.318 Henry and value of C is 159 microfarad. We are having all these values and we have to solve this circuit here. First of all, what I will do? First of all, we have to calculate XL. XL is what? 2 pi into F into L. 2 pi into F is what? 50 hertz. And here voltage is 240 volt. And L is what? 0.318 Henry. So XL will be equal to 100 ohm. XL will be equal to 100 ohm. Okay. Second, so Z1 will be equal to what? Z1 will be equal to what? R1 square plus XL square. R1 is what? 50 plus XL is what? 100. So on solving, you will get the value of Z1 is equal to 112 ohm. This will be your Z1. Now, what will the angle? Phase angle. Because in RL circuit, as we have discussed, first of all, in this branch is simply what? Series combination of RL circuit. So what will be the phasor diagram for this? Here, if it will be the current, then voltage across R will be here and voltage across inductor will be at 90 degree ahead from the current. This will be your VL. So overall, what will be the V? This will be your V. So there will be a phase angle between voltage and current. Voltage will not be 90 degree ahead or 0 degree from the current. Voltage and current will have some phase angle. So here we have to find that phase angle. How we will do that? Phi 1 will be equal to tan inverse XL upon R. Sorry, it is R1. So tan inverse XL is what? 100. And what is R1? 50. So the value of phi 1 will be 63.5 degree lagging. Clear? So here the current I1 will be equal to I1 equal to V upon Z1. V is 240 and Z1 is 112. So current will be 2.15 ampere and phase angle is 63.15 degree. We will draw the phasor diagram for voltage and these two current I1 and I2 later. First of all, let me calculate some parameters that are related to this question. Now, for the second branch, we are having R2 and we are having C. So first of all, we have to calculate XC, 1 upon 2 pi F into C. So what will the value? 1 upon 2 pi into F is 50 and C is 159. This is 159. Okay. 159 microfarad into 10 raised to power minus 6. So what will the value of XC? XC will come out 20 ohm. First part is done. Now what we will do? We will calculate Z2. Z2 is equal to what? R2 square plus XC square. So the value we have to put here, the value R2 is 75 ohm and XC is 20 ohm. Let me do the solution, and the value will come out to be 77.7 ohm. This will be the value of Z2. This will be the value of Z2. Now what will the value of here? The second branch is series combination of R and C. So we have drawn the phasor diagram that if it is current, then this will be the your voltage across R, and the voltage across C will be like this. This will be your VC. So overall the voltage will be like this. So current and voltage are having some phase angle, and the current is leading from the voltage. Here voltage is before the current. I mean to say current is ahead from the voltage by some angle phi. So the nature of phase angle will be leading. Current is ahead from the voltage. So what will the phi 2? Phi 2 will be equal to tan inverse Xc upon R. So tan inverse X is what? X is 20 and R is 75. So the value will be equal to 15 degree, and nature will be leading because it is series RC branch. Now I2 will be equal to I2 V upon Z2. So V is 240 and Z2 is 77.7. So the current will come out to be 3.09 ampere. Clear? Now what we have to do? We have to draw the phasor diagram for current and voltage. Let me take voltage as the reference phasor. Clear? So what is current I2? I2 is 3.09 ampere with 15 degree leading. So current will be drawn here. This will be your I2 with an angle of 15 degree. Clear? Current is leading from the voltage by 15 degree. Now what is the significance of I1? How we will draw I1? So I1 is equal to 2.15 ampere and it is 63.5 lagging. So current I1 will come out here. This will be your I1 and the angle is 63.5 degree. So overall what will be the current? Overall the current will come out somewhere here. This will be your I resultant with some angle phi. We have to find that angle phi also, and we have to find the value of current. So here the current can be divided in two components like x component and y component. So what will be the value of current in x direction and y direction? So from this phasor diagram we can divide the current in components. So what will be the x component? Here from this phasor diagram we can divide. This will be I1 cos 63.5 degree and plus I2 cos. Here let me write x component. X component will be equal to what? I1 cos 63.5 degree plus I2 cos 15 degree. What is I1? I1 is 2.15 multiplied by cos 63.5 plus what is I2? I2 is 3.09 multiplied by cos 15 degree. So the result will come out to be 3.94 ampere. Here this will be the x component of current. Now y component will be equal to this I1 and can be drawn here with negative sign, and this I2 can be drawn here with positive sign. So it will be minus I1 sine 63.5 degree plus I2 sine 15 degree, because I1 will be drawn here with the negative direction. The sine component, y component of I1 current will be here, and the y component of I2 will be here. So it is negative and it is positive. Clear? Put the value of I1 minus 2.15 sine 63.5 degree plus what is I2, 3.09 sine 15 degree. So the value will come out to be minus 1.13 ampere. This will be your y component of current. So now what will be the resultant? I resultant equal to under root x component square plus y component square. X component 3.94 square plus minus 1.13 square. So it will come out to be 4.1 ampere. So here we are having the resultant current. Clear? What will the phase angle? Phase angle will be equal to tan inverse y component upon x component. So tan inverse, what is y component? Minus 1.13, and what is x component? 3.94. So it will come out to minus 16 degree. So what will be the overall phase diagram of the circuit? Phase difference between voltage and current. Here if it is voltage, then current will be like here and angle will be 16 degree, and the value of current will be 4.1 ampere. And what was the value of voltage? 240 volt. Here it is your phasor diagram. Now what will the overall impedance of the circuit? Z will be equal to V upon I. V is 240 volt. Current we have calculated 4.1 ampere. So overall impedance will be 58.5 ohm. So it will be your impedance. Clear? So this was all about the phasor diagram method. Now in next we will start with the concept of phasor algebras. The same question we will solve this question by the method of phasor algebra. Clear? Thank you so much.